Hey, third graders, we're going to start a new math unit today, and we're going to talk about perimeter and area. Area probably sounds familiar to you because we have talked about that before, so we're going to revisit that along with this new concept of perimeter. And what that is the distance around a figure. So think about like a yard that's fenced in. The fencing, right, would go around the yard, and that would be like the perimeter. So let me show you a little picture here of this chart. Okay, so here's a rectangle, right? And I have it labeled. One side is 3 centimeters long. The other side is 5 centimeters long. Now, when I figure out perimeter, all I have to do is add up all the sides. Okay, this figure has 4 sides, but I've only labeled 2 of them. Do you know why? Well, on a rectangle or a square, right, the opposite sides are the same length. So if the bottom one is 5 centimeters, I know the top one is also 5 centimeters. Okay? The same with the one here on the left. If that's 3 centimeters, then the one opposite is also 3 centimeters, because in a rectangle, opposite sides are the same length. So to find the perimeter of this figure, this shape, I'm going to add up all the sides. Okay, so I'm going to add 5 plus 5, because those are the 2 sides, the top and bottom, and then 3 plus 3. Those are the 2 on the left and the right. So when I add those numbers all up, 5 plus 5 is 10, plus 3 more is 13, plus 3 more is 16. Notice my label is centimeters. That's what we're measuring by. We might be measuring in miles or inches or feet. Pay attention to the label. Okay, I added those numbers up and I came up with 16. So the perimeter of this shape is 16 centimeters because I'm just measuring the outside. What I could really do, let's say this was a string, I could take the string and lay it out all the way just in a line. And if I measured that line, it would be 16 centimeters long. Okay, so perimeter is the area around a figure. Okay, around really the outside of it. Now we've already talked about area before. Okay, and I hope you remember that area is the total number of square units that cover a figure. So think about like a blanket covering something. If I have another rectangle, I'm looking at what's on the inside, right? It's covered in square units. Sometimes our units might be in centimeters or feet or meters. We have to pay attention to that label as well. If it doesn't give us a label, they're square units, okay? Just squares, basically. You remember that the area is on the inside. I have the word inside a figure so that you can remember that. Okay, but another way we could count to find the area, but another way to find area is to look at the length and the width. Okay, you'll notice the length. I have 2 squares, and then the width, how wide something is. This one is 3 squares wide. So I can multiply those 2 numbers together to find the area as well, if it's too big and I can't count them all. So area is the length, how long something is, times the width. Okay, as long as this is a figure with the same, right, the same ones. Sometimes we have extra ones sticking up, right? Then we can't do it. We would just count the squares. But it has to be equal groups. So area is the length times the width. So for this particular one, I said the length was 2 units, 2 square units. The width was 3 square units. 2 times 3 is 6. So when I finish, I'm going to add my label. The area is 6 square units. Whenever you label area, you have to have the word square before the measurement. This might be meters or miles or inches, but it has to be square because we're talking about the number of squares on the inside. All right. So we're going to look in our math journal today on page 309. To get started, we're going to do a couple pages today. Okay, page 309. and we're going to do some on the back. And remember, we're talking about perimeter and area. So make sure you're thinking as we're talking this through and you're taking really good notes. Okay, in the vocabulary beaver, it's got perimeter and unit square. Okay, the squares are on the inside, and we'll talk about those in just a second. Remember, you can always go to the glossary in the back to find the definitions. Okay, so it says on this page, the dots on the dot paper are 1 centimeter apart. So all these dots. Did you know that on the back of your number path whiteboard, you have a bunch of dots that are also 1 centimeter apart? Okay, this is going to be a great resource for you to use when we're drawing and practicing. Okay, because you can connect the dots to make one length. So if I were to start at this dot and connect it to the next dot, right, that's one length, 1 centimeter. What if I were to connect all of those? Then I have a shape, right? I have a figure. So the perimeter, this is 1, 1, 1, and 1. So the perimeter, I would add those all together, would be 4 centimeters. And I told you, these are all 1 centimeter apart. Okay. For my area, I could multiply the length times the width, or I could just count, right, how many square units I have. So the area is 1 square centimeter, since we know we're measuring in centimeters. Okay, so if you can't find your number path, try to find it, because you're going to be able to use it during this unit. All right. Let's look at page 309. Here's that figure, and it's in 2 different colors. So you'll notice that around the outside, it's red. On the inside, it's yellow. So let's learn a little bit about area and perimeter and answer some questions. Okay. The first question says, what part of the rectangle is its perimeter? So looking at this colored rectangle, right, you know that the outside is the perimeter. So that would be the red sides, right, the red lines. So we're going to write the red sides, because that's what these are. These are sides of a figure. This happens to be a rectangle. Okay, number 2, which is right across, says what part of the rectangle is its area? So remember, area is on the inside. So that would be the yellow inside. Okay, so perimeter is around the outside. Area is on the inside. Okay, so let's find the perimeter and the area of this particular shape. Okay, I'm going to show you a couple different ways to find perimeter, kind of the way the book teaches us, and then one of the ways that I like to do it as well. I always pretend that I'm a bird in the air, and this is like a bird's eye view. I'm looking down on top of a table, or on top of a parking lot, or on top of someone's yard or garden. So I'm flying in the air and I'm looking down on it. Okay, to find the perimeter, I think, okay, I'm going to mark every time I count in between, right? So in between these dots is 1 length. So I'm going to count. Here's 1, 2, 3, 4. So I'm kind of counting the space in between. 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So every space has a tick mark, okay? And I counted 22 tick marks. Remember, these are 1 centimeter apart. So my label is going to be centimeters, and that's the abbreviation for centimeters. Here's another way I like to find the perimeter. Okay, I think about this as someone's table, and I kind of draw chairs around the table. So I kind of connect the dots. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, and 22. Okay, I still have 22 centimeters, but when I look from the sky now, I sort of think those look like chairs around a table. Okay, so whichever way is easier for you, you can draw, right, that hop, or you can make a tick mark, right? But you need to make some kind of mark so you know whether you've counted it or not. Okay, I also want to point out there are 2 on this side, which means there are 2 on the opposite side because this is a rectangle. Okay, how many are here? 1, 2, 3, 4, 5, 6, 7, 8, 9. That means there are 9 across from it. If I add these numbers up, 9 plus 9, the double is 18, plus 2 more is 20, plus 2 more is 22. I add up all the sides and I get 22 centimeters. Remember, they gave us the label centimeters. Okay, now, if we're going to find the area, we're going to find the area on the inside. And it says to draw square units to help. Okay, so I'm going to connect my dots and I'm going to make squares on the inside. I'm going to draw one long line in the middle there. Now I have a bunch of squares on the inside, and I can just count them. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I have 18 squares on the inside. So that means my area is 18 square. We're going to write units, right, or centimeters, because we know that we're measuring in centimeters. So square centimeters. Okay, you could also abbreviate the word square by putting an SQ, okay, if you don't want to write the whole word out. Remember, the other way I told you is you can multiply 2, the length, times 9, the width. 2 times 9 equals 18. Whoops, 18 square centimeters. Okay, so lots of different ways to figure it out. Sometimes we have, look at here, we have 2 equal rows, but sometimes our shapes are odd sized, right? They have extra little parts and pieces. They look like buildings. So we can't multiply the length times the width if it's not equal rows or equal groups. Okay, let's look at number 5, because we're going to draw a rectangle that is 4 centimeters long and 3 centimeters wide. Okay, now in this book, we're going to change this because they typed it wrong. It's not going to be 4 centimeters long. It's going to be 4 centimeters wide and 3 centimeters long. They made a mistake when they printed this book. Okay, we don't have enough space to do it the other way. So if it's 4 centimeters wide, that means I need to connect my dots. There's 1, 2, 3, and 4. We're not counting the dots, we're counting the spaces in between. 1, 2, 3, 4 wide and 3 long. 1, 2, 3 long. Okay, now we're just going to connect them all to make a rectangle. It said to draw a rectangle. And then we're going to find the perimeter and the area. Okay, the perimeter. There are 3 hops over here. 1, 2, 3 on that side. 1, 2, 3, 4 on this side. 1, 2, 3. My alarm for my Zoom is going off. And then 4. 1, 2, 3, 4. I already knew that because this is a rectangle, and I know that the opposite sides are the same length. Okay, so for perimeter, Remember, perimeter is when I add all the sides together. Okay, if this were a shape that had 8 sides, I would add all 8 sides together. 4 plus 4, I like to do my doubles. 8 plus 3, 3 plus 3 is 6. 8 plus 6 is 14 centimeters. We're not counting squares. Remember, this would be like having a string around the outside, and I just took the string and I pulled it apart and made it long. It would be 14 centimeters long. Okay, area, that's on the inside. That's that yellow part above. This is where I want to count my squares. So I'm going to connect my dots to make squares. That's why having that number path whiteboard with the dots on the back is going to be really helpful, because it's hard to draw squares, right? That they're all the same size. Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 square, because there's squares, centimeters on the inside. I could have also found it by multiplying the length times the width, right? I don't need to worry about this side when I'm doing area. I'm only multiplying what we call the side lengths, 3 and 4. So that's the other way you can find the area on the inside, but it has to be of a rectangle, right? It can't be funny shaped. Okay, let's answer this question, and then we're going to look at the back side. Okay, this is where we get into some of those funny looking shapes. Okay, so let's see, number 6. It says, explain how you found the area of the rectangle in exercise number 5. So we did it a couple different ways, right? One way we did it was we multiplied. So multiply, we're going to say side lengths, because that's what those are called, and you need to know that math vocabulary. So we're going to write 3 times 4. That's one way we did it. The other way, count the squares. Right? Lots of different ways. Maybe you did 3 and plus 4, or 3 here, and then you added 3 more, and then you added 3 more, and 3 more. Or maybe you added 4 plus 4 plus 4. Right? Maybe you did some repeated addition. Maybe you went right to multiplication. Okay, so let's do repeated addition. Right? Because you could add 3 rows of 4. So 4 plus 4 plus 4 more is 12. Or maybe you added your columns of 3. And you did that 4 times. You still get the same answer, right? 12 square centimeters. Okay, and as we do these lessons, I expect you to be thinking about this math vocabulary. You should know what repeated addition is, right? And you should know that multiplying is a shortcut for repeated addition, right? That's all you're doing, is adding numbers over and over and over. Remember that perimeter is around the outside of a figure. The area is on the inside of a figure. Okay, so let's look at page 310. This is where it's got some strange looking shapes. Okay, and it's asking us on every single problem to find the perimeter and the area. So I'm going to go and I'm going to make a plus sign. I'm going to circle those. So that is a reminder to myself that I need to add all the sides together. Okay, so I did that on the whole page. There's only 6 problems. So let's work on it together. They've told us that it's centimeters, right? All of these dot pictures are using the same measurement, just like it is on our number path dot board on the back. All right. So perimeter, if I'm going to count, right, the spaces around the outside, you could do it like chairs. You could do the tick marks, right? Or you could just simply count. 1, 2, there's 3 on this side, which means there's 3 on this side. Well, this is a square, so I know that all the sides are the same. Okay, so to find the perimeter, I have to add up all the sides. I'm going to write this equation out. 3 plus 3 plus 3 plus 3. I have 4 sides of my shape, so I have 4 measurements. Okay. 3 plus 3 plus 3 plus 3, what is that? 3 groups, 12 centimeters. Remember, it's on the outside, so we're not squaring anything. But the area, we're just going to count the squares on the inside. There are 9 square centimeters on the inside of this shape, right? 3 here, and 3 here. We could have also multiplied our 2 side lengths. Okay? And it's nice and easy because this is a square. But look at down here. When we get into some of these other shapes, I can't multiply the side lengths because they're not the same, right? There are 4 on this side, there are 2 on this side. Well, what about these guys, right? They aren't part of the shape. So I can't always multiply the length times the width if it's not a rectangle or a square, all right? Let's try number 8. So here we're going to do the perimeter around the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So my perimeter around the outside is 16 centimeters. Now I need to count the squares on the inside. So I'm going to connect my dots so that I can see the squares. 1, 2, 3, 4. What did you come up with? Count them if you didn't do it. 12 square centimeters. Okay. So we've been practicing using squares and rectangles, right? Now we've got some really funny looking shapes. Okay, so we're going to have to add up the sides of these, and they're going to be different. Not each side is going to be like the opposite sides are not going to be the same. So let's try this one. Here's 1, 2, 3, 4. I'm going to write 4 there. 5, 6, 7, 8, 9, 10, 11, 12. 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 chairs around this table. Okay. If you don't like doing those kind of hops, remember, you can make tick marks in between, but remember, you're only counting the space in between. You are not counting the dots, not counting the dots, okay? Now we've got to find the area. Remember, that's the covered part on the inside. So we have to connect those dots to make those squares. 1, 2, 3, 4, 5, 6. There's 6 squares. So 6 square centimeters. If these were bigger squares, like these friends, these are inches. Our label would be in square inches then. But we're counting by centimeters. We're measuring in centimeters. Okay, let's do a couple more. The perimeter, so around the outside. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, that has a perimeter of 12 as well. Look at, these are 2 completely different shapes. But we could still fit 12 people around this table and 12 people around this table. But they're different shaped tables. Think about the squares. How many squares can we make by connecting the dots? 1, 2, 3, 4, 5 square centimeters. Okay, these are funny shapes. Okay, pause the video and see if you can solve them and then come back and check them. "16 centimeters. So I could put 16 chairs around this table, but there's only 7 squares on the inside. Okay, for this one, we got 14 centimeters. We could put 14 people around that strange looking table. And then let's check the squares. Hopefully you got the same thing I did. I count 6 squares, 6 square centimeters. Okay, I went pretty fast because I was giving you the answers to check, right? You shouldn't be doing them with me. Your job was to do them and then come check them. Okay, so remember, perimeter is around the outside of a figure, and you add up all the sides. Okay, there's a song that I could sing. Perimeter is around, perimeter is around. Oh, oh, don't you know perimeter is around. You add up all the sides, you add up all the sides. Oh, oh, don't you know you add up all the sides. Sadly, I don't have a song for area. Okay, but if you can remember that the perimeter is around the outside, you add them up, you can remember that area is on the inside, right? It's the number of squares that's covering the shape, and you can count those. All right. Look in Google Classroom today for your assignment to show that you are an expert on perimeter and area.